Today in this video, we're going to discuss collections and how they are used in C#. The four main areas that we're going to cover are arrays, indexes and subscript, out-of-range exceptions, and lists. While there are different types of collections other than arrays and lists, we're just going to focus on those two today. So what are collections? So far, we've been only working with variables that store a single value. What do you do if you need to work with a bunch of variables of the same type? Creating 2 or 3 integers isn't a big deal. What about if you had to create 100 integers or 1,000 integers? And what if you needed to manipulate all of those, like add them together or print them out? That would be a lot of work to hand code that out all individually. Collections allow us to group together variables of the same data type to create, manipulate, and access them easier. A little bit about arrays, we're going to cover those first, is that these are the most basic type of collection. Think of them like a container for a variable. Each variable held in an array is called an element, and there are 3 important things to remember about arrays. Arrays can store any type of data, but all elements must be of the same data type. So if you have an array of integers, you can't put a string in that array. You'd have to have a separate array to hold strings. The number of elements in your array is set when it's created and can't be changed. So you need to know how many elements at maximum you're working with in your array, because if you need a larger array, you're going to have to create a whole new different array. If not given an initial value when created, elements are given a default value. So for instance, if you're working with numbers like an integer, it'll just be defaulted to 0, and other types are set to null. So if you have a string array and there's no string being stored in there yet, it'll just be equal to null. The egg carton is a really great example of how to visualize an array where we can store, obviously, eggs. This carton was made specifically to store eggs, and it's of a fixed size. It can only hold 12 eggs. If we needed to hold more than 12 eggs, we would need to create a whole new egg carton. You can't just, expand it out very easily. You'd have to manufacture a whole brand new one. So our egg carton can hold like Easter eggs, and we don't have to fill it up. We can have as many in there as we need. These would just be, set to null. But if we ever needed more than 12, we would have to get a whole new egg carton to hold that. And just like an egg carton, we do have the ability to add more eggs, change out eggs, and manipulate the eggs that are currently in there. Like if we wanted to replace that pink egg with a purple egg, it's not a big deal. We can also add more eggs if we need to. So if we needed another egg, we could add another egg to that. And if we don't need data anymore, we can also we can null out that element in there, but that spot still remains, that we still have the ability to put something back into that slot. Also, since this carton was made specifically to hold eggs, we can't put things that are not eggs inside of our egg array carton. So unfortunately, we can't store kittens inside of egg crates because they weren't built for that. So we cannot put things other than eggs inside of our egg carton. So as far as writing arrays in code, we do need to make sure that we follow the correct array syntax. And it's actually very similar to how we declare a variable, where we first need to tell it what data type it's going to be. So what types of elements are we planning to store? We then do an open and close square bracket, and then we name the array just like we've named every other variable. The difference, though, is what happens on the other side. And even if we are going to make an array that's not currently holding anything, we still do need to write this on the other side of the equal sign, where we write out the word new, the data type again, and then inside of the square brackets, we tell the computer how many elements do we plan to have in this array. So again, arrays can be any data type, but everything in that array has to be of that type. An example of declaring an array would be like this, where you say the data type, the square brackets, and the name of the array. You would then say equal to new, that data type again, and then inside of the square brackets, how many elements in the array. So this particular array is going to have 3 elements. You can also assign values to the elements in your array when you declare it, so you don't always just have to leave it blank. There are 2 methods you can do this. You can, the first half on the left is the same for both empty arrays and ones with values at declaration, where you write the data type, the square brackets, and then name the array. You can then set it equal to the word new, that data type again, and the square brackets, but you can leave out how many elements are going to be in there because you're about to do that right here. You then have your curly bracket open. You then list out all of the elements in the array, separated by a comma with a closed curly bracket at the end and a semicolon. So this will make a 3-element array. So if you do plan to give it values at declaration, note that it makes it the size of your array is going to be how many elements you put in there. So you can do it like this. You can also just say, int square bracket, the name is equal to, and then in your curly braces, all of the values. But again, this is going to create a 3-element array, and you won't be able to change that number after this line of code. An important concept to understand with arrays and other collections as well is this idea of indexing. So how do we access the different elements in our array? We do that by knowing its index. So we would just say that the position of an element in the array is known as the index. So the last important thing about indexing, before I go into the example here, that you probably want to note to yourself is that the first element in an array is always at index 0. So we don't start counting at 1, we start counting at 0. So if we were to be working with this array here, we would say that 452 is at index 0, 713 is at index 1, and 984 is being stored in index 2. So the indexes are 0, 1, 2, but it's a 3-element array. If we want to go back and look at our example of the egg carton, and we were to label out the elements in the array, we would say that the purple egg is at index 0, the green one is at index 1, the blue one is at index 2, and the gold one is at index 3. And even though the indexes go from 0 to 11, we would still say the length of the array is 12 because it has 12 elements in it. So how do we actually access all those different elements? The way that we do that is by using the subscript operator, which is what we refer to those square brackets as. Inside of there, we put the element's index number to access that specific element. So we can use this to read, what's being stored in there, and we can use this to write what's being stored in there. So if we need to just print it, we can. If we need to change it, we can. So for example, we have this array of integers called exam grades, and it has 3 elements. We didn't set the values here at declaration, so we're going to have to go through them and set them now. We would do this by first accessing the first element, 0, and setting it to 75. We can then access 1, which is technically the second element, and set it to 80. And then to get the final third element, we would have our subscript operator with a 2 in it and set it to 95. We could do this in any order we wanted to. Don't think that you always have to access them in order. We could have set the last one first, or we can always change this also after the fact. So this was just put in order just to make it a little bit more legible. Then if we wanted to print them out, we access that element by having the name of our array, our subscript operator, with which index we want. So this is concatenating all of the elements onto the string so that it can be printed out. So length is one of those properties that you're going to find that you're accessing a lot when it comes to arrays, because sometimes it can be useful to find out how many elements are in an array. And we can do this with using the length property. So for instance, if we have this this array here called exam grades, we can store its length inside of this integer variable by setting it equal to the name of the array dot length, so that we can easily print out that information down here. There's going to be a lot of instances where you're going to need this knowledge. It's going to come in handy in the next lesson when we start talking about looping, for instance. Let's take a look at what this looks like in code. There will be a follow-up video where we're going to work through some demos regarding arrays, but just so that you have a little bit more familiarity with it, let's look at this very simple int array that I coded into the script. So I did make this a class scoped a variable up here. You're going to find that working with arrays, a lot of the times you are going to make them at the class scoped level so that other methods can access them and that information stays. It's very difficult, and it's not something we're going to really get into in this course, to pass arrays to methods. So if we need to access this array in multiple areas, like for instance, we're using it in start, and we're using it in this method here to print out one of the elements, we need to have it class scoped so it can be accessed in both spots. It will also save the information so that it can be used in other, after our methods are done, it doesn't disappear. So if we did have our void update still, and we were just going to raise that whatever's being stored in there by 1 during each update, we can do that. If we had declared this here, rather, so it's scoped just to start, it's not going to know what int array is in these, because start just fires, and once it's done, it's done. So after it goes at the start, this int array disappears. Update won't know what that is because it's gone. So you're going to find most of the time, unless you're using it to store things just for that specific method, and you don't need it after that method, you're going to be doing a lot of class scoped arrays. So kind of make sure you kind of keep that in your head. So I declared it up here as a private int with curly brackets. I'm sorry, the square brackets. I gave it a name. I set it to new int 5. So that this will have 5 elements. I then just kind of did a real quick where I set that first element, because remember, the first element is actually at index 0 equal to 10. And then I have this very simple method that's accessing that. Oops, let me get rid of this now. Accessing that and just printing it out, just to kind of show you that if you did want to access this down here, you can send information about the index if you were trying to access a specific one, but ultimately, most likely, most of the arrays you're going to be working with are going to be class level arrays. So we could also, if you want to see this real quick, what it would look like if we wanted to print out the length of this array, it would just be int array dot length. And again, look for the demo video, and we're going to have a lot of practice working with arrays in Visual Studio and Unity. The last thing I want to touch on with arrays is one of the main errors that you might see working with them. And this will only occur during runtime. You won't see this error until you try to run your code, and it's called an index out of range exception. And this occurs because arrays have a set number of elements when they're created, and you get this index out of range exception if you try to access an element that doesn't exist. This is the error that pops up, and it'll tell you which script it occurred in, as well as the line it happened in. So something happened in this learning curve script at line 12. So most likely what you're trying to do is you're trying to access a element that doesn't exist. So for instance, if you think about our egg carton from earlier, what if somebody asked you to get element 12, because it's like, hey, there's 12 eggs in here, so I want the 12th egg. You're going to get an out of range exception because there is no index 12. It's 0 through 11. That tends to be the most common when people are learning how to work with arrays, is you're usually trying to access the next one when it doesn't exist. So that's why it's also very important to understand that indexes start counting at 0. So even though there's 12 eggs, the last egg is at index 11, not index 12. So we're going to move on from arrays and talk about the next collection type, which is lists. And lists are similar to arrays, but they do tend to be a little bit easier to work with, but they do also have higher performance costs when it comes to arrays. So we're at a simpler level. We're not, high-end computer scientists. We're not really too concerned about performance costs because, we're working with games. They tend to be kind of, heavy anyways. So if my personal preference is to work with lists instead of arrays, especially with game stuff, because they are easier. And the main difference with lists is that you can add and remove elements after the list has been created. And so when it's created, we don't have to set the element count like an array. So we can just start with an empty list, and as we need to add things to it, we can just add. If we need to take away things, we can just take away. We don't have to be constrained to our egg carton. We can have it as big or as small as we need after it's created. A great example, seems kind of cheesy, but think of a shopping list. It's called a list for a reason. Like, you can easily add groceries to it as you think of things. As you buy them, you can take them off the list. And if you think of more things, you can add them on the end and you can remove them. Just like arrays, though, you can only store one data type in a list. So like on the grocery list, if it's a grocery list, it should just be groceries. It shouldn't be a list of chores that you need to do for the day. So you would have a different list of chores. Same thing with lists in C#. It's an int list, it's a string list, it's a game object list. Each of them, it has to be consistent, just like an array. So the syntax for a list is a little bit different. It's close, but it's a little bit different. The big difference is that we have to write the word list with a capital L, and then we use the the triangle brackets to put the data type in. So, it's kind of in a weird way flip-flopped a little bit, where arrays, we write the data type and then we have our square brackets to indicate it's an array. We have to write the word list and then in these triangle brackets put what the data type is. We then write the name of our list. We give it a name just like a variable or array, and then set it equal to, we write the word new, the word list again, we get our triangle brackets, and we tell the data type one more time, and then an open and close parentheses and a semicolon. So again, just to reiterate, that list can be of any data type, but everything in it must be of that type. And since the list length can be changed later, we don't really need to specify its length. So usually if you aren't adding things at start or anything like that, you would just write out, for example, that exam grades int. If we're making it like a list, we would just write this instead. If you do want to put values at declaration, it's very similar to the same way that you did it for an array, where you write out the list just like before, but you can use your curly brackets to open and close, and then what goes in between them is added to the list right away. We access list elements the same exact way that we access them for an array. So I know that we use those weird like triangle brackets to declare lists, but we access them with that same square bracket that we used for an array. So for instance, with the exam grades, if we needed to change what was stored in that first element, we would use that subscript operator with the name of the list, the subscript operator 0 for the first element, because again, elements start at 0 in lists, just like in arrays. And then we could set that equal to something else. If we wanted to print it, we access it the same way. Name of the list, our square brackets, and which element. So what if we needed to add another element to our list? We can alter ones that exist in there by using those square brackets, but what if you needed a brand new element? This is where we would use the add method that comes built in with lists. And it's very simple. We just write, we have that exam grades list that we've been showing in this PowerPoint. If we needed to put more grades into there onto the end, we would just write the name of the list and do a dot add. And then inside the parentheses, we put the value that we want stored in that new element. This will put the new element on the end of the list. So, keep that in mind. It's not at the beginning. It would put that on the end. So if we were to look at the values, we had previously, these ones, it would go 75, 80, 95, 75 again, and then 90. So this would be at index 3, and then this would be at index 4. You can also add new elements at specific indexes, even if it's right in the middle. And we do this with the insert method. So we can specify which index you want the new element to go in, and it will shove all the other elements down an index. So you can use this to insert things at the beginning. So what if you needed, in this example, we're putting this at index 1, so that would be right here. So it's going to insert 100 after 75, and then 80 and 95 are going to get moved down an index. So it'll go 75 at element 0, 100 at element 1, 80 at element 2, and 95 at element 3. So this is the index you want to put it at, and this is the new value. And if you wanted to put this at the beginning, you would just put a 0 here, and you might end up, that tends to be one of the more common ones, is to insert things at the front of your list instead of at the end of the list with the add method. There's also the remove method. You can delete out elements in your list. So, think about the grocery list. Once you find the item at the store, you don't need it anymore, and you remove it from your list. And there are two ways that we can do this in C# if you need to remove an element. There's just remove at. So you see this exam grades dot remove at. And then in the parentheses, what you put is the index of the element you want to remove. So if you do remove at 0, it's going to remove that first element there, that 75. So your list will then just contain 80 and 95. We can also do it by value. So if we, for instance, instead wrote remove 75 rather than remove at, it's going to find 75, that value of 75, and take it out of the list. So if you don't quite know where the element is, like what the index is, but the value you need it taken out of, you can use remove to just take that one out. And also keep in mind that it doesn't create like an empty element. It destroys the element and then shifts the index of the ones after it down by 1. So it's not like there's a blank there. It's just actually a smaller list. So with all of these adding and removings, you might lose track of how many elements are in that list. And it's a little bit different to find out how many elements are in your list versus in a array. Because remember, we could do array, we could just do that dot length. It's different for lists. What we use instead is count. So rather than dot length, you just do dot count, and it returns an integer of how many elements. So make sure you don't get those two mixed up. Dot length doesn't work in lists, dot count doesn't work in arrays. So remember which one is meant for the length of the list, which is dot count, and which one is meant for the length of a array, which is dot length. So this was just a brief, explanation of lists. I don't really have any coded examples of it to show, but if you go on to the next video with the demos, we are going to have a lot of experience working with lists by the end of that one. I didn't want to extend this video out too much longer because we're hitting on about almost a half an hour. So we're going to save looking at code for lists for the next video.